It should have just started just right now. Okay, it started 2 seconds too late. Okay, thank you very much. I did start it, but it was still processing. So let me just go over that again. Okay, so today we're going to do linear discriminant analysis for classification. And I'm going to first do some theory, and then we're going to jump in to the Excel. So linear discriminant analysis is a supervised learning technique, and we're going to look at it for the classification purposes. And it's also going to, for this case, we're going to reduce the dimensions or the amount of variables. So we're going to use it as a feature selection tool, basically. So we're going to have um, in um, in your course, especially in the Python part as well, we're going to do LDA and PCA, which is similar. It's just the two different versions of it. So LDA is supervised, so you have a supervised learning, and you have linear combination. So if the features are predefined classes, you know what the answer is. In PCA, it's principal component analysis. It's you don't know. There's no class labels. So it's creating class labels. You want to group it. So that's the two different ways. But we're going to look at the LDA, the linear discriminant analysis, and we're going to look at the statistics behind it. So how do we do this? So linear discriminant analysis also is now looking at, there's my pointer, looking at all of the points for, let's say, these two variables. We're going to see what is in common. So we're going to work out the distances. We have already worked on Euclidean distances, especially in the KNN, and we're going to now look at the errors as well, but we're going to look at more than one variable. So I'm going to show you guys how to work with more than one variable. So that we can also have it. So in this case, we have before LDA, yes, we have groupings. You can see there's two different types of dots. So we have dots and we have triangles. After LDA, we have made that the distinction is a bit more clear, so we grouped it. So we spaced it. Yes, there's some that's still in the other corner, but it is grouped better. So it's easier to understand. So this is how I can visualize it for you. So we have classes, we have categories, and within that classic categories, we're going to group it together. So in this case, we have a grouping, and in the middle of the grouping, we're going to have the mean of the distance of those grouping. So it's the difference of the groupings together, and we're going to get it so that we can get like a midpoint or an average of that group, so that we can find to which group it can belong or which ones has an influence on each other. So I'm going to, in this case, in this pretty little image, it is a grouping. Yes, we group it. We can see, okay, this has an influence. We can see now which variables has an influence on each other there. So it's going to give us an indication of which variables are important. And the variables which are important is going to help us then create our models, but that model building is going to be done in your coding next year, or if you're already doing the coding, we're going to do it later this semester. So the assumptions of LDA is that it forms a normal distribution. So a normal distribution is, I'm quickly going to try and draw just a normal distribution. The average normal distribution is usually a bell curve. Oh, this is horrible, but there we go. So it is usually a bell curve, which is a normal distribution, and a normal distribution also has, as the data increases, it normalizes. So it then centers around a certain average or certain point, and that is why we assume that it has a normal distribution, because if we have more data, it is the law of large numbers. Okay, and then the nonlinear data is also going to be highlighted in this, because it's going to help us choose the data characteristics or the data that we want to use and make sure that we're choosing the correct ones. So LDA, as you can see, is logistic regression, but it assumes normal distribution. So logistic regression without the assumption of normal distribution is your normal logistic regression. But LDA is we are assuming normal distribution so that it can be used across bigger data sets and different data sets. Okay, so mathematically, we're going to look at, we have two classes. So we have two classes in this case. We're not going to work with too many, but I'm going to start with two classes. And it's d-dimensional. So it is, if you have a matrix, it has d amount of rows and d amount of columns. So it is x to the power, well, x, all of the x's, and x to 1 to n, but that n is going to be the d because it's d-dimensional. It's d amount of samples. We're going to first look at two classes. So we have N1, sample belongs to class 1, so C1, and N2, sample belongs to class 2 sample. So Xi is the data point. So the Xi's, the X's, is the data points. And we're going to project it into a line to get it as a vector. So it's going to be written as a vector of t, x, our I, and I'm going to show you how we're going to use this now in Excel. So we're going to find the mean of each and every class, and that is written, the mean is written as this mu. So it's mu1 and mu2. So we're going to get the two means of the classes. It's this picture. So we're getting the mean of the class 1 and we're getting the mean of class 2. Then we're also going to find the variance. So the variance is where it's just outside of the class, or there's three different variances. So we have the variance, and then there is a distance that we look at. So the variance is used to determine how we're going to handle that data point. Oh, sorry, wrong slide. There we go. So after we have the mean, we're going to normalize it. So this is also how we're going to use that, the assumption of a normalized distribution is we're going to get the absolute value of the differences of the mu's. So the means, so it is the projected, so it's the predicted. Oh, this is not a highlighter. There we go. It's the projection, or it's the predicted new mean that we're going to calculate, and we're going to get the absolute value of it so that we can assume normalized distribution. And that's going to help us, since the more data we have, the more data tends to normalize. So this is our next calculation, is our variance. So the variance is going to be for both classes as well. So we have the variance for class 1. We have the variance for class 1, which is the sum of all of the data points minus the data point of that class. Okay, so the data points in the class and the data point of that class. This is important. I'm going to show you guys how we're going to do that. Then we're going to get the new projected mean, and we're going to get the absolute value. So absolute value is important. We want it to be positive. So we want a positive value. And we're going to divide it by the variance. Okay. This is also going to then be used to calculate the eigenvector. So the eigenvector and eigenvalues, I do not think I'm going to have enough time to show you how to do the eigenvectors and eigenvalues from scratch, but I am going to add links. So there's links for you, and I'm going to show you how what you need to do there as well. So first we're going to look at practical implementation, and we're also going to look at the iris flower again, and I'm going to look at how we can use it. Yes, Tabiso.
Sorry, Nadia, if you can go back to the previous screen.
This one?
Yeah, I think I've also seen on the group, on the WhatsApp group, how we get traumatized by formulas. I was wondering if you can make it easier, if you can now, with the first formula there. If you look at that first formula, you're talking about the sum of xi EC1. I understand that pair of a factor there on xi minus mu1. So if maybe you can explain, when do we read that EC1?
I'm going to do it in the Excel sheet, but
Okay. Okay,
no
if you're gonna do
problem.
it,
No,
no,
no.
sorry, if you're gonna do it, then I'm fine with
Let's
it.
let's quickly talk about it as well. So that E is the element. So let me just move this. So this E, this E is a notation. So that is the notation of the element of. So it's a notation of the elements of, and that C1 is your group 1 or your class 1. So that's your first category. So you're going to look at all of the X's, so all of the data points, all data points that are elements of your first group. Okay, but I am going to highlight it again in the Excel sheet as well later on. Yes, Kat?
Um, just please correct me if I'm wrong. When you mentioned
Oh,
d-dimensional before, are these two elements an example of that d-dimensionality?
yes, the d-dimensionality is basically the whole data set.
Oh,
So
so here in this case, there's two variables, so there's two d's.
yes,
Oh, okay.
it's the d's inside of the data set. Yes.
Got it. Thank
So that's why I didn't pause too long on it. Okay, so I'm going to look at the iris flower. It is also, the D is our whole data set, and in this case we're going to have 3 different classes, and this is where the D comes in. So we have the distance of D, one of each class. So it's going to give us the distance to the new point, and that is going to be the D is actually the mean, or uh, the predicted mean after we've done our calculations over all of the variances for each and every group. So this is just, instead of writing X or N, we wrote D. So it's just to make this picture look better, make sense, because we don't always find all of the pictures to be
Okay.
exactly the same. Okay, I have added a lot of
Limal.
I have added a lot of useful links for you, especially on linear discriminant analysis and what you can also read up further on, because we can't always get to everything in class. So I'm going to say the 3 key assumptions or basic principles is we assume normal distribution. We assume that the covariances are equal amongst the classes. So in this case, we are assuming that the classes or the categories has the same amount of data points. And then we assume independence. So we assume that the features or the variables does not have an influence on each other. So I am going to Yes, okay, so carry on still. So we're going to identify a linear classification, and we're going to separate it in different classes. So that is our different classes or our different categories. And it is going to, we want to maximize our bias variance. So we're going to maximize the variance between classes so that we can distinguish them better. Okay, and we're going to also do that in Python as well later on, but here is the strength. So it is better to group data because it's then easier and more effectively to run it, because sometimes you only have a computer and not a whole server to run data on, and that makes it computationally better or easier. And it's also a classification tool. So in this case, we do have the categories, so it's easier to classify it into which category it should go. But if you did not have a class categories, then the PCA, which is similar concept, it's just without the categories, and you're going to then find the categories. Okay, so it does struggle with nonlinear data though, and it's the outliers does tend to skew it. So if you look at, I'm going to go back to this one. So if you look at, if there was a red dot in here at the blue dots at the very end, it is going to skew our data for the blue class. So it is very sensitive to outliers. So that's why we want to look and make sure the outliers are correct and removed. So this is the Python code, but you guys are not going to do that now, but I'm still going to leave it in for those that wants to go and play around. Now I'm going to go over to the Excel spreadsheet because that is the main one that I want you to focus on. Okay, there we go. So yes, cats.
Why would someone choose LDA, for example, over KNN? Because it looks like you're doing the same thing in clustering, but KNN looks like is looking at a specific distance from each point. But what is the why LDA over KNN, for example? Like they look so similar. How do you know?
That is a good question. So it is usually we use LDA when dealing with more complex non-linear boundaries. Yes, we use the same data set because it is clearer so that you guys can see the distinction, but it is not always as clear. We just want you to at least know now what it should look like. So I can say also KNN is flexible and it has a higher accuracy, but it does not do well with complex structures. So
By
um,
nonlinear, did you say? Wait. Am I remembering? I thought you said it doesn't do well with nonlinear because of the outlier. This is LD. What was it? LDA.
LDA, yes.
So I'm
Um,
I'm I'm a bit confused.
no,
Sorry, I
no,
was just
it's
trying to understand this.
let me just paraphrase it better. um, I switched it around. Thank you very much. So LDA assumes the linear decision boundaries, and KNN is when there's no clear linear decision boundaries. So if you look at, oh, I have now closed that one. Oh, there we go. Okay, so here we have two groups, and you can see there is definitely a separation. So it is distinctly no interaction between the two, and it is then easier to separate it. Whereas KNN has it mix up it overlaps. For KNN it overlaps more, but we can do both. So LDA and KNN. I would say LDA is like a precursor to KNN. So you first look at the LDA, you look at the variables, you look at the variables that has an influence, you look at what they do to each other, and then you choose the KNN model. So LDA in this case, we're going to use it to choose our variables.
Got you. Thank you.
Okay, so in this case, we don't really have a big data set. So we have our, already we have our species, which is our flowers of iris data sets, and we have already, we can see there is 3 different groups. So in this case, we know it's going to work with KNN, but I just want to show you the background of how you can decide it. So this is also, I have a few steps here that I have wrote down, especially for the Excel part as well. Yes, Tabiso.
Yeah, another thing, wasn't it the logic, what is that? The logical regression. I think we did that.
Logistic regression.
Logistic regression, also part of grouping or classifying. Is this now the same as logistical regression? It's just another link.
Okay,
If I want to.
yes, so you do the LDA, so you use the linear discriminant analysis. So you choose your variables before you choose now if you're going to do logistic regression or you're going to do KNN. So this is a step in the process, and I'm just showing you how the background of that step works, because this is not a model. So this is not the model, it's just before you use the model. So you're choosing your dimensions, you're choosing your variables. So this is before you choose if you're going to do KNN, linear regression, logistic regression. Does that help?
Yes, ma'am. Thank you.
Okay. Okay, so let me carry on. Okay, so for this, I have a few steps in Excel, and I will share all of this with you on ARC as well. I have your step 1 is your dimensional mean. So in this case, here you have just rewritten it. I've rewritten this whole this data as just as a matrix. So you have a matrix of your labels, which is your species, and you have a matrix of your inputs. So your input variables in this case is just the petal length and petal width, and it is going to be then just 2 columns in this case, but that is your matrix. So your matrix, then you're going to have it per species. So for the species, I'm going to group it per species. Okay, and then you're going to get the mean, which is the average of each species. So we have Setosa, which we can group together. We have Virginica, which we can group together in a different group. And we have Versicolor, which we can group together. So you have your 3 groups, and so you're going to have to get 3 mean values. So how do you calculate the mean? It's going to be all of the values, or all of the values of that now data point, sorry, all of the data points added together, divided by the amount of data points there are. And then we're going to, in step 2, look for the variance for each and every grouping as well. And I have made it here on this slide. It is going to be clearer for you because I have all of our variables I have our species, and I have our species key. We are going to get the prediction, our y hat. We're going to get the predicted group, and we're going to see if it is correct. So this is going to be, then I have, in this case, the species, I have grouped it. So I have went and ordered it so that the first grouping, all of the setosas are together. And for the species keys, I chose the setosa to be 0. So it's going to be group 0. And we are going to now use all of this. So how am I going to use all of this? I am first going to get the data. I'm going to do the linear regression. So where is my regression? I'm going to do regression. We have our y's. So we have our y, which is our species. It's our species key. And you can go and choose all of the species keys. There we go. That is our y. It's our y, and we're going to get all of our inputs. In this case, we have more than one input. So we are going to choose all of the columns. So in this case, I am going to choose all of the variables that we need. There we go. And I just need to add the label of the y columns for myself as well. So this is also how you guys are going to do your regression analysis in your assignment as well. And I have added the labels. So when I chose the columns, I highlighted the labels as well. So I'm going to tick the labels. I'm going to put it in a new range. I put the output range so that I can have it here on this page so that I can just use it on the same page. I don't need residuals. I just need the first few calculations. So there we go. There is my summary output, and it is perfect. Perfect. So this is how you are going to do it for the rest as well. Yes, Tabiso.
Nadia, you're about to send me straight to ICU now. On the other data set, you had 2 features there, and now I see 2 more extra features.
It was just I didn't
Or you didn't scroll to the other
yeah,
side.
I didn't scroll. It
Yes,
was my
no,
own
I
fault.
nearly got to ICU now.
Yeah, but
Thanks.
it's the same data. It's just that this is the steps and this is the explanation, and then there is it summarized for you. So I did a few steps. So it's just going over it step by step as well, so that we can do it together. Okay, so this is now we're going to use our regression analysis. So you guys know this one, right? We have our predicted y is going to be our y hat. We have B0 is our intercept plus our coefficients for each and every variable. So we have 4 variables. So we're going to have 4 coefficients. So I am going to use this equation. I'm going to use it to get our y hat, which is our predicted value. So first, let's go and look at, we have our, we've done our linear regression analysis, the data. So the data analysis, we're doing a regression, and we have done that. Now we can see that here, this is the easiest way for you guys to get it. So this is why I'm showing you, because now we have beta 0, we have beta 1, beta 2, beta 3. Oh, 3, and beta 4, which is our coefficients. So this is also what you're going to then use, especially in your assessment. You guys should find the coefficients, you should find the intercept, and you should find all of your values, and then you can get your y hats, right? So this is why I'm also showing you this step, because then you know where to find this. Okay, So we're still busy now with that. So let's start with, okay, now we're going to get our y hats. So, oh, there we go. So this is going to be equals to our intercept. So you choose this value plus your sepal length, and then you're going to multiply it by your sepal length. Oh, I forgot one extra step. You have to lock it in. Okay, so you have to lock in your coefficient, otherwise it's not going to work. Okay, then we have now our sepal length. Okay, now we need our coefficient for our sepal width. There we go, sepal width. We're going to lock it in, F4, and then we're going to multiply it by our sepal width. Okay. Then we need our petal length coefficient. Petal length coefficient, and we're locking it in. We're multiplying it by our petal length, and then we're going to get the coefficient of our petal width, lock it in with F4, and multiplying it with our petal width. Okay. Oh, what happened? Why is this one not working? Did I? Oh, okay. I need to lock that one in properly as well. So our coefficient, yes, that's fine. Adding all of the values, multiplying it with each other. Let's see if I just need to take out the brackets, if that was what was wrong, because sometimes we do make errors when doing things. Okay, let's just multiply it instead of doing brackets. Okay, so it was the brackets. Don't put the brackets in, guys. Okay, and then we can just populate the rest of the table. Now in this one we can predict the group. So here I have written it out for myself as well, because this is quite a lengthy one, but I am still going to do it with you. So we're going to say which one is the predicted group. So it's going to be an if-else statement basically. So we're doing an if-else statement in Excel, guys. So the logic test. So if this value, no, that's not, what is it? G2. I feel like I've missed one of my values that I should have calculated. Okay. I know what I've missed. Okay. I have not yet done the rest of my calculations. So we have our y bar, y hat, and now we want to get our predicted group. So we have to get the n, so it's the count, so it's the amount per of the groups. So we're going to see how many observation or data points there are in each group. So this is now part of this step. So we're going to now do the steps first. And oh, this is also, you can sort it. Okay, so I did actually put in the sorting, so you guys can sort the data by species. And I have forgot to do that because I've already sorted it. Okay, so this is the step that I have missed with you guys, but I still have it here, and I have put in all of the explanations. So that is also why we're going to do it. I have done this part, and we are now going to calculate. So we're first going to do this part now. So we're going to count, say in this case, I'm going to count F. So sorry, just count, not count F. You guys can use a count value, but count F if you figure it out. It is, you are more than welcome. So count, and I'm going to count all of the zeros. So all of the Satosas, and I'm just going to stop at 0. And then you can also do that count F. Then you can choose the whole column, and then make it that count if it is 0. So that is also possible. You guys can do that. There's more than one way of doing this. We will not mark it wrong. Okay. And now I want to count all of the ones, so all of the versicolors, and they should all have about the same amount of inputs, if I'm correct. Count, and I need to now count my Virginicus. There we go, the 2s. Count all of the 2s together, and we have 50 entries. There we go. Yes, they are all the same. We have 50 entries for each and every group. So this is our category. So this is our class 1, and we have class 2, and we have class 3. Okay, now we're going to get the averages for each and every of those classes. So we're going to get the mu. So this is that. So we're going to get the average of each and every class. So how do you get the average? It's easy. You just get the average, and we're going to count the predictions. So there we go. We're going to count the average of the y-hats. Okay, so that is our prediction. It's our prediction. There we go. That is our prediction for class 1. Our prediction for class 2 is going to then be the y-hats for our 1s. Just choose the 1s though, just making sure about that. You can also, I think there's an if-else average statement. I haven't figured it out yet, but if you guys know it, please share with the rest, because that would be amazing. Otherwise, we can just do it like this. There's more than one way to do maths. There's more than one way to get to the answer. So it's not going to be incorrect. It's just a different method. Okay. So now we have those y bars. We have the values that we need. So in this case, we have our y bars. So this is our average score for each group. So it's our discriminant analysis group. Okay, so this is, scroll up to the very top. Okay, and then if we have now the averages, we have the counts, then we can now get our C1 and C0, which is going to be our category. So it's going to be basically like, it's going to tell us where it belongs. So if it is above, below C0, which is our grouping, it is in group 1 or group 0, which is the TOSA. If it is between C1 and C2, which is basically just a value, it's our cutoff value, it's going to be in our versicolor. And if it's above C1, so if it is more than C1, so the value is more than C1, then it is in our Virginica. So it's just helping us group our y-hats. Okay, so let's go and calculate now our C1, 0 and 1, our cutoff values. So let's see. We have our cutoff values is going to be our, this is the, sorry, the equation as well is our cutoff values equation. Where did I write down the equation, guys? Did I put a nice equation in here? I didn't. There, no, that's the variance. Ah, where is my lovely equation? Okay, I will add an equation for you guys. So we have that we're going to get in the, it's going to be our class 1, so N0, and it is going to be multiplied by our average. Okay, so we're going to put, oh, this is also on top, so it's going to be our cutoff value. So it's going to be the n class 1 n amount times the mu bar, and it's going to be plus our class 2 multiplied by the n value. Sorry, by the n value multiplied by the mean. And that whole section is going to be divided by our n1 plus. Remember the bracket, guys. The brackets are important. Okay, divided by our amount. Okay, oh, there we go. I missed that one. There we go. There we go. Okay, and that one just moved, I think. There we go. So that is our cut-off value. So this is our cut-off value for our group 1 or our class 1. So this is class 1's cut-off value. So this is going to help us see where the cut-off value for our predictions are. Okay, so this is basically an even more manual method for grouping data. Okay, and then we're going to get our second cutoff point, which is going to be 2 double brackets because it is now class 1 and 2. So it's class 2, sorry, multiplied by the mu of class 2, and we're going to add the amount of class 3 multiplied by the mu of class 3, and it is divided by their added amounts together so that we have our second cutoff value. Okay, so this cutoff value we are going to use, that cutoff value is to get the predicted group. So I'm going to see if I can just copy and paste. Well, it's not really easy to copy and paste always, but we can rewrite it or just refer to it. There we go. Okay. So I am going to go back here. So we have C0 and we have C1. And how are we going to use it to get this predicted group? I'm going to scroll down all the way down to all of my lovely little notes. And we are going to use this if and statement. So this is our determining it. So we're determining our groups of predicted values and we're using the cutoff values. Okay. And then I'm going to copy paste this here up here because otherwise I might type something that should not be that is different than what we should have, right? Okay, so let's see. We have an if statement. We have an if statement. We have our y hat, and it should be if the y value is less than our C0, and we can lock that one in. It should be in the class group 0. Okay, then this is basically another if statement inside of it. So if, I think maybe, oh, okay. So mine does not like commas. Mine does a comma point. Okay. So if, there's my next if statement. So we have 2 if else statements together. Okay. If and, so we're going to have, if it is greater than our C0, so that value is greater than our C0, which you can lock in again, and smaller, so the smaller, oh, it's still a comma point, and that value is smaller than our C1 value, which we can lock in again. Then it is going to be 1. So then if it is between these two cutoff points, it's going to be in the predicted species of 1. So it's going to be the versicolor. And then we have our last one, if both of them are false. So if previous to is false, so then it's else it's going to be 2. Okay, so because that's the only one that's left. Okay, and then yes, okay, cool. So I just forgot to add one more bracket at the end. Okay, and then you can now populate the whole table, or you can double click it and it will populate it, and there we go. So we have 1s and 2s everywhere, and now we can go and see if it was correct. So if it is correct, let's actually see. We can make an if else statement. So if it is correct, so logic test. So if the predicted group is equals to our species key, which we know is correct, then we can say it is yes. So you can also say 1 or 0. And in this case, I just used no, yes and no. Okay. So if it is correct, yes. If it is not, no. So let's see. Oh, there's a few that's not correct. So it is a good one to use. And now we can, here I have created a lovely little misclassification check. So it's going to be count equals to count if the whole section, so this correct, there you go. If it is, I have chosen the whole column. If it has any no values inside of it, it will count it. Okay, and I'm going to use the exact same formula. So it is count if, oh, no. Sorry, it's count. I am going to just copy paste it. Why? Because I am not going to go and choose the whole one again, but now we can just change that no to yes. And there we go. So we have 4 that is misclassified, and we have 145 that was correct. And now we can just get the percentage, which is basically our number of our number of yeses divided by our total value. So we have 70, it's 97% accurate. Okay, so this is going to help you to get a new observation value. Yes, Setsu.
Hi, I just wanted to know, aren't we missing one more? Because in the initial count, all 3 classes were 50, but now we have 149.
That is true, yes. Where did, oh, maybe I did not choose all of the data. No, I did choose all of the data points. Oh, I know what happened. When I just copy pasted it, that is where it broke because the range moved 1 down. Okay, so let's just choose the whole section. There we go. So when I copy pasted it, it just moved from I3, from I2 to I3, and then from I151 to 152. So that is that's where it changed. So luckily the percentage total is still the same. Thank you for picking up on that one. And yes, Susan?
Do you mind just explaining the cutoff point and the if
Oh,
statement again?
okay, no problem.
Thank you.
So the cutoff point is our the class 1 multiplied by the class 1's average plus the class 2 and its class 2 average divided by the count of those two. So it's going to give us the cutoff 1. So this is, we have the cutoff of class 1, which is all of the class 1s should be below this value. So we're going to make a prediction. The prediction is that all of the y-hats that is below that C1 value, which is our class 1 cutoff. So it is our class 1 cutoff value, is going to be in the is going to be a setosa. So it's going to be our class 1. Our class, our C1 is basically, this is our class 2. So our class 2 cutoff value, but it is that all of class 2 should fall within C0. So it's greater than C0, but it is, so it is greater than C0. We're going to say that's an X, so that is our prediction, and it is smaller than C1. Why? Because this is going to tell us that this is our class. So it's going to tell us class 2 is between these two cutoff points. This one is going to be, I'm just going to write it out again as well. So this one is when X is smaller than C0. So X is smaller than C0. That is written better. There we go. So this is our cutoff point for that one. And then for our cutoff point basically for class 3. So class 3, the cutoff point is X is greater than C1. Okay, so we have grouped our 3 categories. This is how we grouped our 3 categories. Does this help? This indication?
Yes, it does.
Okay.
And just one more question. So I'm seeing that none of the values will be like included since you did like less than or greater than. So will we ever have a situation where one of the class's values is equal to the cutoff point, and then if that's the case, which class would it then fall into?
That is a good option. I did not use less than or equals to, did I?
Mm.
And less than or equals to. That is a good question. I think I need to go and reevaluate my equation there, because that is a valid point, because it should be less than or equals to, let's say less than or equals to, and this one is greater than or equal to. How do you write that? That is a good point, because it, thank you for seeing that, less than or equal to, in Excel. How do I get that into a equation? Oh, okay, so that is actually a very good question, and luckily it is an easy to fix one as well. Where did I calculate it? It's in this equation, and we are just going to add an equal sign. Add an equal sign to the very beginning, because if it is greater than, oh, that greater than one does not want to work. Okay, so let's say if it's greater than just, and that one should be less than or equal to instead of just less than. So this one is going to be a less than or equal to. So there is 2. That is our differences.
That isn't a formula, by the way. You never said equals if. You just said if.
Yeah,
Maybe that's why.
it could be yes. So if we change this, will it break? Let's see if it's gonna break or not. It did not break. Okay, so that works. It is less than or equals to, like that one. And this one is less than or equals to C1. Why? Because I don't have a greater than or equals to on this side. So it should be greater than or equal. Oh no. I need to change that one. There we go. Then let's see if it is actually going to influence it. So did it influence our answer? Which let's go and see if our correct yes or no changes. No, it did not change our answer. Thank you very much for picking up that. There we go. So I changed it here. So that is going to be there. Yes, Dominic. Or John.
I think if you put the equal sign in front of the greater than sign, shouldn't that also work? So no. So after G2, no, go back. That you
Yes.
had that right. That's less than and equals to. And then after the and statement, it says G2 greater than.
Oh no,
If you put the
it should just be greater than, because
oh,
we have
okay.
already x is smaller than.
Oh,
We
okay.
have x is smaller than or equal to C1, so we cannot have class 2 as smaller than or equals to, because then if it is the same, then it would be in both sections. So
Oh,
we
okay.
have to make that distinction.
Oh, okay. Thank you.
Yes. Okay. So that's why there's only 2 great equal signs, because it has to now, class 2 has to now be greater than. It has to be bigger than, since we chose that class 1's cutoff value can be equals to that value. And then class 2 or class 2's cutoff value is included, and everything above it, so class 3, is greater than. Okay, so that is why we have it where we have it now. Thank you very much for picking up that one. It would not have made a difference except if something broke. So I am very glad you picked up on that one. Okay, and then this is your, then you can see, okay, if it is, your prediction is very nice. We have a very great prediction. So this logistic or this regression model is very nice and it works. And now we have our observation. Our new observation is then going to be, I have a new observation here of 3 values. So it's the petal length, width, sepal length, and sepal width. So we're going to now get our new observation, and we're going to use that if else statement to see in which category it belongs. So we're going to have our equation, which is here at the very top. So it is our intercept plus our new value. I should actually just copy paste a few down here. Our new value, which is 55, and it is times by our coefficient of our sepal length plus our new value, which is given as 32, multiplied by our sepal width plus the new value, observation of 15, multiplied by our petal length coefficient, and then we're going to get our last one. There we go. We have our 3 times our sepal length. There we go. Or petal length. And then we have our new observation, and we're going to use this if else statement now. So we're going to say if And now we have that value of the cell is smaller than or equals to our C0, which is up here. So you can go and use it where you have saved it. Otherwise, you can rewrite it down here at the bottom. Then it's still 0 and if. So our next if statement, and we have our value cell is greater than our C0. Why? Because it is, it has to be greater than. I'm going to type it in. Okay, and then the value less than or equals to our next value. So that is going to be that value. So C1, and we close the brackets, comma point, then it would be 1, otherwise it would be 2. Close brackets, enter. Okay, so we predicted is Setosa. There you go. So this is our Setosa. And I have just added the extra part here for you guys. This is all that we have done. And this is just basically a bit more compact. So this is, there is also a type of question like this in I think your second assignment. I'm not quite sure. I need to go and look at that. The assignment changed from last year, so I need to go and make sure about that. Other than that, I have, this is your t-tests, but I wanted to show you here just for this one. So this is just to show you to do the regression analysis. So here we have an ID, a feature. So we have 4 features and we have a class. So I want to just show you guys again, just to make sure you understand the regression, especially with more than one variable, because I know you guys have this with the KNN and with the regression analysis, there's more than one variable. So we're going to choose our Y range. In this case is class A, and I think this one is going to break because I did not put it into numbers yet, but let's see. And then we had our features, which is features. We do not need the ID column. I added the labels and I'm going to put it in output range here. Let's see if it does not break. It does break. Why does it break? It breaks because our classes isn't defined. So we have A and B. So we're going to encode it. So we label our classes and let's A be 0. And you can also here have an if-else statement if you guys really want to do that. You can, or you can just go and type it out. So this is an extra class for you guys on just some extra functions. So you can have the if class A is equals to A, so in quotation marks, otherwise it doesn't know it's a string, so it doesn't know it's a letter. And then I have, if it is true, then it's 0, else it is 1. And let's see if that works. So we're going to populate it. Yes, okay, it works. So that one did work. You guys are more than welcome to use it. So this is basically just an extra class for you guys. Okay, then we're going to get our regression analysis. And we are going to choose our label class as our Y. And we have our input ranges is all of our features. And we have our labels included, and my output range, I'm just going to move a bit on. And I'm going to say, okay. So there we go. We have our labels. And you guys did have a class on the t-test and the f-tests, or there was an extra class on that, but you guys can still go and rewatch that. And now we can get our y hats, because y we have all of our coefficients. And even though there are some zero values in here, you can still use it. We don't know quite why it is there, but we can still use it. Okay, so this is how you can get your multiple of r. You can get your r squared. You can get your standard errors, your adjusted squares. You have 10 observations. You get your coefficients. And this is how you guys can just do it. So this is just an example to show you guys how to get the data using the data analysis tool. But you guys will be able to do it, and I am confident you guys will be able to solve it as well. I don't think you guys have an LDA question for assessment 1, but do you guys have any questions on assessment 1 while I'm here? Because this was my whole LDA class for you guys. Yes, Lawrence?
Evening. I just wanted to know, do we have a way in which we could review with someone, maybe library or someone, just help review the work you've done, or what
For the
tools are there to help us
references,
just review our work? Not
is it
necessarily references, just to see whether or not you are on the right path.
you can message me in Teams and I can have a look at it, since I'm also I'm both the tutor and the lecturer in this case. So as a tutor, I can help you and just also look over to see if you're on the right track. So you're more than welcome to Teams message me. I'll get to it as soon as I can. Luckily this week I do have more time for you guys. Yes, Susan?
Are we allowed to ask like specific questions like in the assignments? Because I just wanted to get clarification on question 3.2.
3.2. Yes, you're more than welcome. I don't think you guys are going to be able to see the assignment probably, because it usually just blacks out. You'll probably only seeing a black screen. But let me quickly just 3.2, right? Okay,
Yes.
so the distance between the three nearest neighbors. So K3. Okay, so I'm going to quickly open my lesson that I had with you guys. There we go. Okay, so here you have your K values, or your K, well, this is for a tumor, but it is also the same. These K values, you can go and sort now. So you can see, okay, there's 1, 2, and 3. So the question was sort the training data by distance and identify the 3 nearest neighbors. So here, in this case, we have ranked the Euclidean distance. So you have already done it if you have followed this blueprint. So you have the rank, and then you can just go and rewrite it. So you can see now K value 1. I've just sorted it. This is where I've sorted. This is the sorted version of this one, basically. So now I can see, okay, the first 3 values was, let's make it orange, okay, was benign values. So that is your training data by distance, and you have identified that it is benign. So this is your sorted value. You can just give us this part. Does that help?
Yes, thank you.
Okay. Any more questions? I think there was one question I had that someone else asked, is the mode. So that is, I think, question 3.3. So the question was, determine the most frequent class amongst the top 3 nearest neighbors. State the predicted class for the test example. So in this case, it is first the most frequent one is the mode value. So our mode is our most frequent occurring value. And how you can do that is literally you can here is 9 KNN values, and you can literally just go and use the mode function. Mode function, the mode, and you choose your labels, and it will give you 0. And it's then we have the most frequent occurring value in our K values is 0, which is benign. Or in your case, it could be 0, which is Setosa. Yes, James.
My question is on, I think, on the part 1 of the assignment.
Okay, part
For
1. Oh,
question
that's
1.
the theory
Question 1.
questions.
Yes,
Okay.
the theory question. My question is, do we need references for some of those? Because I think
Yes.
we do.
Yes, yes. Please, guys, reference all of the, especially question 1. All of question 1 needs referencing. The rest does not need referencing because it's practical. So the rest is quite practical. You don't need, yes, you don't need references for the rest, but question 1 needs references. So I would suggest you guys do question 1 on a Word document, and you reference it. We have a Harvard style referencing that I have shared, not in your group yet. I will share the Harvard style referencing guide that we use in EMERIS so that you guys can have the correct referencing method. You have to have a reference per fact, basically. So for each fact that you have to reference. Okay. Then we have, I hope that helps. Is that clear, James? Okay. Michael.
For the referencing, does it have to be academic journals, or could we use websites like Geek for Geeks and others like those?
You can use websites, and you can use academic journals, but you guys can use websites. It's perfectly fine, except you guys, please do not, please, 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 I'm begging you, do not reference ChatGPT. It's not a reference.
How do we start?
I have had many of them, and I'm crying. You cannot, you can ask it for where he got its data from, and then you can go and look for that data, but
Okay.
do not reference OpenAI or ChatGPT, guys. I've cried many a nights. Other than that, be careful. Do not use Wikipedia because it is an editable website. The rest of the websites are open to use. You can use websites, you can reference YouTube videos, you can reference anything as long as it's referenced correctly. Okay. Nsipo, sorry. Nsipo.
If I can even unmute.
Yes, you can. We can hear
Can you hear me?
Yes.
Okay, great. So I just wanted to ask for question 2 and 3, would you prefer us to create like another tab on the Excel sheets that were provided for the answers, or should we just put them on Word?
Okay. I would say create an Excel spreadsheet because you guys can submit more than one document. So submit a Word document for your question 1 and submit an Excel document for your other questions. What I usually do is I literally go and open a new blank document, and your
Okay.
data points that you have, I don't think I have unzipped it yet. I have not unzipped it yet. I'm going to quickly show you guys what I do. So you have your data points. There is your data point 2. I literally just go and just say enable editing first. Highlight the whole sheet. Control copy, or I say copy. Copy the whole sheet. And then in your new workbook that you're going to save with your student number and your name, you can literally go and paste it. And then you can do it here. So then you have question 2 there. We have a sheet for question 2. You can do all of it here. You can also write out your questions and answers in the sheet. Just label it clearly. so that we
Okay.
can know which question you're on or busy with. So you can literally just use the sheets and create one document, or you can submit more than one Excel spreadsheet. So we look at both of them. So we'll look at everything. Okay.
Okay, so the Word documents for question 1 is fine, and then 2 separate ones for question 2 and 3. That works.
Yes. Yes,
Okay.
that works perfectly. That is fine.
Awesome. Thank you.
Okay. Glad I could help. Then we had Molatela.
Hi everyone. Hi Nadia. A bit of a silly question. Where do we get the data sets for question 1 and question 2 and question 3? I could
Okay.
find the. Okay, thank you.
No problem. It's not a silly question. If you don't know, then you'll search everywhere and not find it. Okay. So I am opening my EMERIS website as soon as it opens. Then we're going to go to the My Academics, or you can just go to your student material. Yours will have less folders. Okay, so yours will just have the folders relevant to you. Mine has a bit more. So I need to go and type in what I'm looking for. Okay, for one, and yours should be, there we go. Okay, awesome. That folder. So this is your this is what your folder looks like, and you have your 2026 term 1 and this one. So this SMAA WA1, which is your assignment 1 preload zip, you can just go and click it and download it. And that is where I have found my data as well. So that is my zip file that I have there. I just labeled it as 2026 because I have a few different ones. And then inside of that data, inside of that folder, if you unzipped it, how do we unzip it? Is you can literally go right click on it, right click, and you say extract all, and you can just say extract. And then it's going to give you a folder that has the same name. Then you have question 1 and question 2. Got it?
Thank you so
Okay.
much. That's helpful.
For everybody else that was also missing it, that is how you find it. Then we have Clinton. Sorry, I'm struggling with some names.
Good evening, ma'am.
Good evening.
Yes. Yeah, it's Nebius. Yeah, it's fine.
Nebius. Ah,
Yeah.
Nebius.
Yeah.
Okay.
So I wanted to ask, which lecture recordings can you like advise us to go through so that we can catch up with the assignment?
Okay, for the assignments, I will, there's YouTube recordings. There's your YouTube link. And for the assignment, I don't think this is in order. Okay, so you guys can go and look at, this is not in order. Okay, so we have lecturer resources. So the supervised learning KNN, there is my YouTube recording for the class that I gave you. I also uploaded an extra video, and I've also done a KNN tutorial. So there is also the OLS. So this is, you can go through lecture resource learning unit 1 for supervised learning in KNN, as well as the lecture unit 1 learning linear regression. So it is reach, lasso, and regularization. I think that is question 1. You have a question on that. Yes, you do. So you can go and listen to those. Then we also have logistic regression. You have a question on linear regression and KNN, so you do not need logistic regression yet. So if you guys go through this lecture resources 1, so supervised learning and KNN, the linear regression, so your OLS, ridge, lasso, and regularization, so all of these ones, you will be able to do the assignment 1. So it's just those 2. So the rest we are going to work on. Also, sorry, also the masterclass for hypothesis testing, because you do have a question. I think it is question 2, where you have to get the p-value, statistical significance. So question 2.6 and yes, so question 2.6. So you guys can also just have a look at this one as well, please.
Yeah,
Okay,
thanks, ma'am.
perfect. Then we have Shonak. Oh, wait. Shonak? I hope I'm
Yes,
saying it.
that's
Okay.
right. Okay. Good
Okay.
evening, Nadia.
Good
I
evening.
just wanted to know if we can submit the assignment to you early, like maybe tomorrow, and can you provide feedback if that's an option?
Yes, yes, you can. I'm not going to overly correct it, but I will guide you in the correct direction. Yes, you guys can just send it to me on Teams, because that's going to be the fastest answering mechanism that I can give you guys. So
Okay.
you have my Teams now also. So yes, you can just
Thank you so
message me
much.
in Teams and send attach the document, and I can have a look at it and give you some feedback. Yes, Michael?
For our lessons, online lessons, how often do they occur? And is there any like way that we can check that we know we're going to see if a lesson is that night or that day?
Okay, so the lessons, so the actual classes is definitely every single Tuesday night. Like every single Tuesday night, except I think on a vacation day, but I don't think we have vacation days on Tuesdays this semester. So it's going to be every Tuesday night. The Saturday classes, so the Saturday master classes, we will let you know, because sometimes we have like this hypothesis testing, F test and T test, that we want to give you guys extra time on, because sometimes there's so much we want to teach you, but we don't always have the time for it. So we will let you know about the master classes, which would happen on a Saturday morning mostly, but we will communicate it with you. And then the tutorials, we are still, my tutorial on Friday evenings will carry on every Friday evening, except last week I gave it to the other 2 tutors so that they also have some interaction with you. They will be going forward as well with tutoring with me. We will also set up extra tutorial sessions so that we can get to everybody's questions, because you guys are quite a big group, although not all of you are here. But I'm glad you guys are here. So we have about 250 students. So that's why we have group tutorial sessions, but we're also available on Teams if you guys need any questions as well answered.
Thank you so much. Thank you.
Okay. So it is the classes Tuesday evenings. The Friday tutorial is definitely going to happen. We are going to also have some Saturday tutorials, and we're also looking to add a Monday tutorial. So you guys should just also, we'll make a poll to get an indication of where the biggest groups are going to be, because sometimes you can join Monday, but you can't join Friday. Or sometimes you can join Friday, but not on Saturday. But we will still cover the same type of content, and all of the recordings. So all of the recordings are here on the YouTube channel. If you go and open it, you will see that I have added the tutorials in here as well. So you're going to see the tutorial on OLS, linear and multi-regression analysis. So I have named it. So there's the masterclass, the synchronous sessions. Those are the classes. So this today is a synchronous session. The masterclass is extra. We have extra videos in it as well, and then the tutorial is the tutorials that you guys can go and watch. Okay, so I've tried to label it as clearly as possible, and the dates are there as well, so we have the dates there as well. Okay, so I have not given a 2-hour lecture. I hope you guys are comfortable at least a bit more, especially with using the regression analysis tool pack. So the data analysis tool pack also going to help you with your question 1 and 3, question 2 and 3, because you can still use that regression analysis pack. We're just for the, actually, you don't need it for question 3 because it's a KNN. If you use the exact same format as I have given you guys, so the Excel spreadsheet, you can copy and paste that format. You're more than welcome to use it. Okay. Any more questions, queries, concerns? Are you guys okay? Yes, Oba King.
Yeah, I think it's a bit of a dumb question or something, but okay. I think I'm kind of confused now. So I witnessed that earlier on when you did what's this, you were busy on a data set that had more than what's this, more than 2 features to it. So it had similarly to the one that we're doing for question 3 on the assessment, it had 2 lengths and 2 widths. And then I witnessed that you took X and Y. So in that instance, which one do you, what's this, do you identify as being the X and which one do you identify as being the Y?
Okay.
Because I think, yeah, I mixed up the two because now I'm reading it as, okay, let me say, for example, it says sepal length, sepal width, petal length, petal width. So I'd read it as the width is the X and then the other one is the Y. So yeah, I'm a bit confused.
Don't worry, I'm going to share my screen again now. And it's going to be on the exact same data set that we have worked on. So if you have here, let's just, I'm going to just copy this one. So I'm going to create a new sheet and I'm just pasting my data here. So for question 3, you have the species is you want to predict the species. So the prediction is what you want to make. So that's going to be your Y. So I'm going to add an extra, there we go. So your species is your Y value, and you're going to have a Y label, basically. So you have a Y column here because you want to get the label of the species. So if you are, let's say if this one is equals to, now I need to very carefully spell it. You can also just go and write down 0, 1, 0, 1, 0, 1. Okay, if it is Setosa, it should be 0. Then I'm going to have if again. So if this is equals to, now I need to also spell it correctly. Versicolor. Okay, this is just one way of doing it. Then I can go back up. If it is versicolor, it is 1. Else it is 2. Okay, so this one did not work. I did an error on this one. So how do you do that? You have Setosa is 0, and I am going to make all of my Setosas 0. My versicolor is 1, then I'm going to make all of my versicolors 1. So this is your labeling. You're labeling it. And my Virginicas are 2. So this is the label that you give it. So you have labeled your data. And you have Setosa. Setosa as 0. You have versicolor. Oh my goodness. Spelling, guys, spelling. Versicolor as 1, and you have Virginica as 2. So this is your Y column. So this Y is your Y column. Why? Because that is what you're looking for. So you're looking for your labels. You're looking for what type of flower it is. And these 4 values, they are your X values. So they are your X1, X2, X3, and x4. So these are your variables. So these are your x variables. So that is your x variables. Okay, okay. Does that help you? So your y label is what you are looking for. So in question, I think question 2, you have a linear regression. You are looking for predict the marks. So you have results, you have interpretation, you have, oh wait, where is, okay, I haven't opened it yet. So you want to predict the marks. So in that case, your y value will be the marks. In question 3, you have your flowers, you have your petals, and you want to predict the flower. So you want to predict the class. So you want to predict the species. Okay, does that help?
Thank you very much. That's
Okay.
clear now.
Okay, perfect. So everybody knows now what to do. So that is how you can use that. And that is, you can also, in the data, in here, so in my lecture resources for supervising KNN, I have not added my, oh, okay. Sorry guys, I have not added my Excel spreadsheet here. I have sent it on the group, but I will add it here today as well, so that you can go and download the Excel spreadsheet that I have worked on, and you guys can use the same format. Okay. Yes, James. No. Okay. Yes. No questions. Okay. Thank you very much for attending, and hopefully also this will help you ease your fears for the assessment, because I'm not sure if you guys had an assessment session. So yeah. Thank you guys. Enjoy the rest of your evening if you guys don't have any more questions. If you do, I am going to be here on Friday as well. So Friday night, you can also come with your questions, and I will also help you then. Okay. Then we have spared one half an hour, so you guys can go and climb into bed, or you can at least have some coffee. Good luck with the rest of the week, and all of the best.
Thank you.
Thank you. Enjoy.
Bye.
Thank you. Bye.